Good evening, students. In the last class, we were discussing about the matrix and the operation on matrices. Addition and multiplication of matrices that we discussed in the last class in detail. Today we are going to have the second topic of the chapter, matrices. A transpose of matrices. If you consider a matrix of order m by n, the topic is transpose of a matrix. If you consider a matrix of order m by n, if you interchange the rows and columns entirely, you will get the transpose of a matrix. Okay, so I'll explain this one with the help of an example. With the help of an example, we'll detail what is the transpose of a matrix. Let A is equal to a matrix 1, 4, 7, 8. Then the transpose will be obtained by, and the notation for transpose is, we'll denote it as A dash or A transpose, AT. We'll note it. So A is equal to, suppose you consider a matrix A is equal to 1, 4, 7, 8. A transpose means is equal to, if you interchange the row completely into column, so 1, 4 will become as a first column. The first row you interchange into first column, it will become 1, 4, and second row will become the second column of the matrix, and this is known as the transpose of a matrix. If you consider another example with the order, this is a square matrix, so you may not understand exactly what is happening. If you go with a matrix of another rectangular matrix, if you consider A is equal to 1, 2, 3, 4, 5, 6. What is the order of the matrix that we discussed in the last class earlier? What is the order of the matrix? It is 2 by 3. That means 2 rows are there and 3 columns are there. So order is 2 by 3. So according to our definition of transpose, what should be the order of the transpose of a matrix? It is denoted by, usually it is denoted by A dash. In certain textbook you can see A T also, A transpose also. So A dash is equal to, will be obtained by, tell me students, what will be that? 1, 2, 3 will become the first column itself. So 1, 2, 3, 4, 5, 6. So this is the topic A transpose, and we are going to have the properties of transpose of a matrix in this class. Okay, there are certain properties for transpose of matrix. I'll write the properties in detail over here. Properties. The first property, if you transpose A transpose, all transpose is equal to A itself. What does that mean? If you find the transpose of a matrix, again you interchange the number of rows and columns you interchange, what do you get? The same matrix you will get. I'll consider with the same example over here. A transpose already we discussed, 1, 4, 2, 5, 3, 6. If you find the transpose of this one, what will happen again? It will be A transpose, all transpose will be obtained by, the column will become 1, 2, 3, 4, 5, 6. It is nothing but the matrix A itself. So the first property, it says that A transpose, all transpose is equal to A itself, and the second property, it says that if you scalar multiplication that we discussed in the last class, Ka all transpose means it is equal to K into A transpose. As we know, scalar multiplication means that K should be multiplied with each and every constant in a matrix. So if you take that one outside, it will not affect the properties, it will not affect the transpose of a matrix. So Ka transpose is same as K, you take it outside, multiplied with the A transpose. Okay, that will be dealing with the example questions. And the third property, it says that if you add two matrices A plus B, we know that addition is possible only when A plus B all transpose is equal to A transpose plus B transpose. What does that mean? If you add the sum of two matrices and if you find the transpose of that matrix, it is same as the sum of the transpose of that two matrices separately. We will be dealing the problems also in the problem section. And the fourth and last property for transpose is, that is very important property, if you multiply a matrix with another one, we know the property of multiplication also, A into B all transpose is same as AB transpose is same as B transpose A transpose. Remember, that is not equal to A transpose B transpose, that is equal to B transpose A transpose. What does that mean? AB, when you multiply the product of two matrices, then you find the transpose, it will be same as B transpose A into A transpose. Okay, that will be dealing with certain examples. With the help of examples, we can have how do we multiply two matrices, and that will be dealing with the and how it is equal to or we have to verify that that is equal to B transpose A transpose. Yes. Let's consider the following example. The question is, find the transpose of the following matrices. Consider the matrix A is equal to 2, minus 1 by 2, 5, 3, 2, 7. How do we find the transpose? A transpose will be obtained by A dash is equal to, what will happen? What is the order of the matrix that you have to keep in your mind? What is the order of this matrix? It is 2 by 3. So what will be the order of the transpose of the matrix? It will be 3 by 2. That means there should be 3 columns and 3 rows and 2 columns. So it will be 2 minus 1 by 2, 5 and 3, 2, 7. So if you simply interchange the rows and columns, you will be obtaining what? You will be obtaining the transpose of the matrix. Is that clear? When you find the transpose of the second one, if you solve the second one, what will happen? What is the order of the matrix? Order of this matrix is, what is the order of the matrix? It is 3 by 1. Why? There are 3 rows and 1 column over there. So order is 3 by 1. So the resultant should be 1 by 3. That means order of the transpose of that matrix will be 1 by 3. So what do you obtain? You will be getting 1 row and 3 columns over here. So it will be 2 root 3 minus 5. So that's a very basic part. Now let's talk about, is it clear for the first problem for all? You can pause the video to note it down and go to the second one, second example. It is purely related to the properties which we discussed already. So let A dash is equal to, that means already transpose is given for this one. It is A dash is equal to 3, 4, minus 1, 2, 0, 1. What is the order of this matrix? It is 3 by 2, and B is already given that minus 1, 2, 1, 1, 2, 3. And we are going to solve and we are going to verify that A plus B all transpose is equal to A dash plus B dash, and we have to verify that A minus B all transpose is equal to A dash minus B dash. And the very important thing which I said the property is A into B, that means product of AB whole transpose is equal to B dash A transpose, B dash A dash. Okay, so let's verify one by one. So first of all, we'll do the solution for this first part. First part we'll be doing it. So first thing what do you have to do? Here a plus b is there, but a dash only given. So the first thing what you have to do is we have to find what is your a. How do we obtain a? We'll be using the property first one again. A dash will be obtained by, or a will be obtained by a dash whole transpose. So what is your a? A will be obtained by a dash all transpose is equal to our a. How do you obtain this one? We have to find the transpose of the first one. What do you get? You will be getting, it is the order is 3 by 2, so it will be obtained by 3, 4 in the first column, minus 1, 2, 0, 1. See what is happening? All the row become the columns of that one, and already given that b is already given. So let's add a plus b first of all. A plus b is a plus b. How do you obtain a plus b? I'll be writing a and b. So addition that we discussed. 3 minus 1, 0, 4, 2, 1 plus b is what? Minus 1, 2, 1, 1, 2, 3. Okay, if I add that two matrices, the corresponding elements has to be added. It should be 3 plus minus 1, it is 2, minus 1 plus 2, it is 1, 0 plus 1 is 1 again, 4 plus 1, 5, 2 plus 2, 4, 1 plus 3, again 4. So you are obtaining a plus b, you got it. Now we have to find the transpose of that one. So when you find the transpose, I will be rubbing the previous part. All of you copied this one. So the second part is we have to find the transpose of that matrix. Transpose will be obtained by what? A plus b. Transpose will be obtained by the rows and columns. You have to interchange it. What will happen? It will become 2, 1, 1, 5, 4, 4. Okay, so that is the a plus b all transpose. Next we have to see the right side. A dash plus, that means a transpose plus b transpose, we have to do it separately. So a dash already we have it. What is a dash? Already it is given in the problem itself. So we need to find b dash only. So what is b dash over here? B dash is the transpose of the matrix, the given matrix. It will be obtained by minus 1, 2, 1, 1, 2, 3. Okay, so and a dash plus b dash, I am doing it separate. A dash plus b dash is, what is a dash? I will be writing a dash once again. It is there in the question itself. 3, 4, 3, 4, minus 1, 2, 0, 1 plus, what is b dash? Just now we found it. Minus 1, 1, 2, 2, 1, 3. Now let's add these two matrices, students. We'll be adding this one, 3 plus minus 1. What do you obtain? What is 3 plus minus 1? It is 2. 4 plus 1. It is 5. Minus 1 plus 2. It is 1. 2 plus 2. It is 4. 0 plus 1. Again 1. 1 plus 3. 4. Now you verify. What is your A plus B all transpose? A plus B whole transpose is same the matrix 2, 5, 1, 4, 1, 4. Here also A plus B, A dash plus B dash is equal to 2, 5, 1, 4, 1, 4 again. What does that mean? The first part has been verified. What do you get? You are obtaining A plus B all transpose is equal to A dash or A transpose plus B transpose. You are getting it. Similarly, what we can prove? A minus B all transpose will be obtained by A transpose minus B transpose. You can note it down and you can take that as the homework. Okay, that you can try by yourself, and we'll be doing the next one. The product of that matrix transpose will be obtained by B is equal to B transpose into A transpose. Okay, so
Bright Education Center, Medical and Engineering Entrance Coaching Center, Hilal area, Doha, Qatar. For further enquiries, contact 306 00679.